Hi everyone. In this video, we are going to see about the sensorless controls in EV vehicles, right? So let us detailly discuss in upcoming slides. Before going into the topic, let us see what are the things that we really need of this particular sensorless controls in AVs, right? So normally we know that both in case of IC engines or the EVs, the control system needs the use of sensors to get the feedback from the either from environment or the working systems of the vehicle to get the data in the form of an electrical signals and process it, and necessary actions can be taken in order to fine tune that particular process. But the real drawback behind the use of sensors is that first it is the since it is a physical component, the cost of the process will get increased by the use of sensors, use of the large number of sensors. So the the first and foremost thing is the cost, and next is the robustness. So the reliable of this particular sensor is a question mark. So we need to look into the reliable of the particular sensors which has been kept in different places in the vehicle, and the dynamic performance. So the dynamic performance also need to be taken in care while considering this system. So for this empathy, we will define the statements. So the first and foremost thing is this particular sensorless control refers to the motor control techniques that doesn't use the physical sensor for feedback. So without the use of the sensor, we are using some techniques where the motor can be controlled without the use of the sensors. And also it can eliminate the sensors, reduces cost, improves reliability, and minimize the maintenance. And can be widely used in EVs, robotics, and industrial automations. So this particular sensorless control system, it first estimates the rotor position and the speed using the current and magnetic flux relationship, and after that it formulates the model of motor magnetic characteristics for the accurate rotor state estimation. And while implementing this, it requires the knowledge of motor parameters and conditions for the accurate estimation of where this particular whether this particular motor is running or what speed is running. So that kind of things, feedback that can be taken. And the challenges and limitation, it includes the parameter sensitivity. So the accuracy is a question mark. So it is highly dependent on the precision of the motor parameters, and sometimes it can lead to the performance degradation. And model complexity. So for developing the accurate mathematical model, it can be a complex one when compared to the conventional sensors one, and also the time consuming one. And also the operating range of this particular sensorless thing is very less. An application of this particular sensorless control, it includes first in our electrical vehicles, where it allows the efficient motor control without the use of the sensors. And industrial automation in robotics and automated system, sensorless control system, it enhances the reliability and efficiency of the operations. And also in home appliances for improved energy efficiency and performance for contributing the smart home technologies. So in this slide, we'll compare the sensorless method with the other methods. So with the sensor-based method, it is a traditional one, but the thing is that we need to use the physical device, and it can lead to failure, and also it requires proper maintenance in the regular intervals. So when we compare to that, it is easy to use the sensorless approaches. An observer based method, so it also estimates the rotor parameters, and also it requires more computational resource and complex algorithm when we compare to the phase flux linkage methods. And hybrid approach, like combining the sensorless with the limited sensor, it can optimize performance, but it cannot give to all kind of the load conditions. So in future trends, it can be integrated with AI, and advancement in algorithm can be done, and the broader adoption can be got with the help of this particular sensorless control, because at present the sensor is dominating each and every applications. So the sensorless control, if we make advancements in algorithms and integrating with the technologies like AI, we can make this thing into a broader adoption in the industries and also in EVs and home applications. So in mind mapping, we'll summarize the session. So we have seen about the introduction, the phase linkage method overview, the comparison with the other methods, the applications, future trends, and the conclusions. So that's all of this video. Thanks for watching my video. Thank you.